welcome to this video. Now in this video, we'll be finding the derivative with respect to x of tangent x using the quotient rule. Now, I want you to look at this. Tangent of x. What could be the derivative of this man here? Alright? So we are going to be using the quotient rule to do this by saying that tangent x is the same thing as saying what? Sine x over cosine x. Right? Hope you know this trig identity that sine x over cosine x is tangent x. Alright, so applying that here, we're going to have derivative with respect to x of sine x over cosine x. Alright, so we're differentiating sine x cosine x, alright, in place of tangent x because it's the same thing from trig identities. Alright, now sine x, okay, let's substitute so that we can make use of our quotient rule. Now the quotient rule states that assuming this y, right? If we call this y, so the y, the x, is equals to v du dx minus u dv dx over v squared, where u and v are functions of x. Functions of x in that we'll make a substitution. Let u be sine x, right? So we call this u. So it's a function of x, and let v be cosine x. So we call v cosine x. It's a function of v is a function of x. So where u and v are functions of x, so we will say if u is this, u is sine x, what is du dx? So that is what is the derivative of sine x. You simply know it's cosine x. Alright? We've made a video on this. Now what's the derivative of v? That is cosine x. What the derivative of cosine x is negative sine x. So this is du dx, while this is dv dx, right? So u is sine x, therefore du dx, the derivative of u with respect to x is cosine x. So if you differentiate f sine x, you have cosine x. If you differentiate cosine x, you have negative sine x. Alright? So we're going to apply that here, where our v is cosine x, and our u is what? Is sine x. So that will become the y, the x, will now become, in place of v, put cosine x, times du dx is what? Du dx is cosine x as well. V is cosine x. So du dx is cosine x. That's cosine square x, right? Minus u. U is sine x. Okay? So the v dx is negative sine x. That's positive sine square x, right? Divided by v square. V is what? V is cosine x. That is cosine square x. Right. So at this point, we can now, split this into two parts. That is to say, we say cosine square x over, and besides, it's either we split this into two sides, cosine square x plus sine square x over cosine square x. Alright, it's either we split this into two parts, or I believe you know that cosine square theta of cosine square x plus sine square is equals to what? It's equals to 1. That's from trig identities, alright? Basic trig identities. That's cosine of a square angle plus sine of squared is equals to 1. So at this point, it will just be 1 over cosine square x. Alright. But if we split this into 2, we'll have this and this cancels out, and we'll be left with 1 plus sine squared x over cosine square x. We define it to be tangent x. That is tangent square x. Right? Since both of them are perfect squares, so we take tangent square x. And as well, from trig identities, 1 plus tangent square theta is equal to what? Secant square theta. And secant is the inverse of cosine square theta. Alright? So it's either you say inverse of cosine square theta, or the addition of this and this is just sec square x. So this is the derivative of tangent x. Sec x is the inverse of cosec square x. Sec square x is the inverse of cosec square x, and 1 plus tangent square x is equals to cosec square. Therefore, the derivative of this is sec square x. Right. Thanks for watching. Please subscribe to this channel.